Okay, so today we're going to talk about rotations. We have a question above, but first of all, we're just going to talk about rotating something in general. So we can rotate in basically two directions if we're dealing on a two-dimensional plane. We can rotate around this way or around that way. Does anyone know what this way, rotating something this way, is called?
Clockwise?
Yeah, that's clockwise. And then what's the opposite to clockwise? Counterclockwise or anti-clockwise? Yes, either's fine. I use anti-clockwise, but counterclockwise is fine as well. So there's two ways. Why is that? Well, that's because the way the clock goes. The hours go that way, minutes go that way, seconds go that way. Okay, and anti-clockwise is the opposite way. So if we're describing a rotation, so something that has twirled around, if you will, we have to use one of these words to describe it. We will also need, so that's one thing we need for rotation. The second thing we need for rotation is we're going to need the angle. So for you guys, there is going to be three angles. Something can be rotated 90 degrees, 180 degrees, or 270 degrees. Okay. So 90 degrees is sometimes called a quarter turn. Why do we think it's called a quarter turn?
Because if it was on a clock, it would turn quarter way around the clock.
That's a good explanation, yeah. So if you wanted to go back to your clockwise explanation, if I started at 12 o'clock and I went 90 degrees, I'd end up here. And that's a quarter way around the full clock. Or 90 degrees is 90 out of a full circle. It's 3 out of 360 is a quarter. 90 over 360. So that's a quarter turn. So 180 degrees then would be a half turn. And then 270 would be a three-quarter turn. So I'll write it as a fraction. Okay. The third thing we need is, once again, a center. Okay, and all these three things combine to describe a rotation. So it'll either be clockwise or anti-clockwise. It'll either be 90 degrees, 180 degrees, or 270. And about what point? So the center of rotation will be a point. Same as center of enlargement was a point. Okay, so get that into your notes, and then we look at the question above. Okay, let me know now if you need more time, otherwise I'm going to start with that question. Okay, Olivia, you can always watch the recording back later. Okay. So let's go to our question. So first of all, well, it's under the heading rotation, so it is a rotation. So I'm going to call this a rotation. Right. So I need to figure out, is it clockwise, anti-clockwise, what the angle is, and the center. All right. So for this, now you won't have it right beside you, but I do. You need see-through paper. Now, I'll have this for you in your next in school, so maybe on Monday, I think. Okay. So you won't be able to do this, but you can describe. So Charlie thinks it's 90 degrees or a quarter turn anti-clockwise. All right. Well, let's see. First thing you do, step one, is trace the shape onto this paper. So I'm going to trace just a sketch. Don't need to use a ruler for this. So there is my original shape. Okay. So I've traced it. I can move it around all I want. This traced paper can be useful for translations as well, because I can slide it up and down how many boxes I want. And you will be given one of these in any exam. All right. But this is a rotation, so it's spun around. Okay. Just listen for now, because you don't have your paper. Okay. So if I just take this shape, I'm just going to take it off the page for a second, and spin it this much, just on the spot. So I tried to just spin that on the spot, this much. How far is that? That's a quarter, yeah. So notice the way, so that's a quarter turn there. Then if I go and do it down here, that's 180 degrees. Spin it around to here, that's 3/4 or 270 degrees. And then when I get it back to its original position, that's 360. So you'd never be asked to do a 360 rotation because it's going to be just back to the original position. Wait, do we have a test? No, you don't have a test Monday. No, you said that. Okay. So I'm figuring out that if I spin it on the spot, that's no good to me. If I spin it on the spot, that's no good. It has to spin to down here. So it must be something is spinning it. It's spinning around a point. So perhaps I can, if I use my pen for a point, maybe it spins around 0, 0. So notice the way, I can spin around 0, 0. But no, that's not getting me where I want. Notice, watch where it goes. It's pretty close, but it doesn't get me onto that point. So 0, 0 is not the center rotation. So where you put your pen and spin it around, that's called the centered rotation. That doesn't work. All right, anyone want to give me a suggestion where I should put my pen next for centered rotation and try spinning it around? I need 2 points. So an XY axis, so Anissa is the first one to say the actual point. 1 minus 1 is Anissa's. So she goes 1 minus 1, so here. Okay, so let's try that one. Spin, 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 spin. Oh, we miss. Not quite. So it's not 1 minus 1. The next one that's actually put in a point, Liwa, he goes 1, 0. So he says here. Okay, 1, 0. All right, let's try that one. Spin, 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 spin. No, misses it as well. Okay, that doesn't work. Let's try the next one that's written down there. Ethan goes minus 2, minus 3. Minus 2, minus 3. Okay. That is well off. It does kind of overlap at one stage, but it looks nothing like, and it comes back to there. Even if you notice that spin it either way, and it's going to form the same circle. Okay, so that's Ethan's out of the running. Ethan, you've already done one, so I won't do your second one. 1 minus 3 from Charlie. So that's 1 here minus 3. So this center here, 1 minus 3. This is Charlie's guess. Let's spin it on that spot. Oh, that's miles off. That's going down into the question. It's way too low, I think. All right, Priyanka's the next one on my list, 2, 0. And Lewis has the same one. So 2, 0 here. Spinning, 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 spinning. Oh, that's getting closer. It's getting closer, but it's still too low. And spin around and end up in the same spot. All right, who's the next one on my list? So Lewis E had 1, -3. We've done that one already. Akin says -1, -1. Okay, that's a good guess. -1, -1 here. All right, let's have a look at that. Let's spin, 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 spin. Oh, that misses as well. It does overlap for a bit, but doesn't form the same shape. So that doesn't work either. Whew. 3, 0 from Osborne. Have I done one of Osborne's already? I can't remember. Okay, that's 3, 0. I think that's way off. It's not way off, but it's too low. Too low. I misses. Okay. Let's try another one. Ezra, 2, 0 has been done. 3, 0 has been done. 3, 1. We've 2, 1 and 3, 1 from a few people. So let's try 2, 1 and 3, 1. Let's do 3, 1 first. Spin, 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 spin. Oh, that's close, but it's a bit too far to the right. So I think 3 was too far to the right. I think 2, 1's in with a chance. Let's put it back. Let's try 2, 1 as our center. 2, 1 here. Spin, 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 spin. I think we have it. My diagram is not perfect. I think that's why, but I think that's it. It's just slightly off. My sketch is a bit rustic looking. If I drew it properly. Let's try that again. I think 2, 1 is our, yeah, I think that's it. My scale is off, but on yours, it should be perfect. I think 2, 2 is the center. So let's remove that. So remember how I did that. It was trial and error, just trial and error. But 2, 1, sorry, not 2, 2. 2, 1 is the center of rotation. True trial and error. Okay. So we worked out the center. Now I need the angle and the direction. Okay, so the angle and direction. Well, let's have a little look again. All right, so let's go clockwise first. So clockwise is this way, this way. Let's try it that way. So that would be 90 degrees. That is 180 degrees. This is, that's 270 degrees. So it's 270 degrees clockwise. Or, if I want to start again, if I went the other way, it's just a 1/4 turn, 90 degrees anti-clockwise. So both answers are correct. They both get you there. Usually the quicker one's better. So I'll write that. Rotation, I'm going to write it here. 90 degrees anti-clockwise. I can't fit it in here, but you can, well, I might try it. Anti-clockwise. Or 270 degrees clockwise. It's the same thing. Let me show you how to do that again. So I put my pen on 2, 1, which I figured out was the center. And then I turn my page until it's flat again. Once it's flat again, see that it's like a rectangle again. That's 90 degrees. If I keep going, that'll be 180 degrees. Next time it's flat again, 270. And the last time it's flat again would be a full turn. So it's 90 degrees anti-clockwise. I went this way. But I could go the other way and get the same. So that's anti-clockwise. Usually go the shortest route. Okay, so have I got everything? I'm going to say width center 2, 1. And then, so this is my answer up here. I'm going to highlight that as the answer. So in your notes, you should see how to describe rotation at the bottom. Did I do point 1 clockwise or anti-clockwise? I did. I said it was anti-clockwise. Did I say the angle? Yes, I did, 90 degrees. And did I say the center? Yes, I did, 2, 1, and I described it as a rotation. Job done. Okay, so similar to enlargements and reflections, we started off by describing one that's already been drawn. And now we need to draw one. Do one given the information, we need to draw the transformation. So I'll give you about 30 seconds to finish off any notes you need on this page. If you've done that already, draw once again a similar Cartesian plane on a next bit of your notes. So 5 each direction again, and then we'll get started on that in a second. Liva, no, just your next one, just draw this blank. To draw an XY Cartesian plane blank, and then I'm going to give you the question. Okay, so hopefully you have started or nearly finished your Cartesian plane, the same as me. This is a lot of Cartesian plane drawing, but they're very important in maths. For instance, the 2 best math students in the school both used Cartesian planes in their final internal assessment project in year 13 in higher level maths. So they'd be relevant. What is the basic one? Ethan, you're asking me what's the triangle we're starting with? Yeah, I'll get to that in a second, obviously. I'm just giving everybody, I know some people are quicker drawing these, but it's important to get this right before we start. So I'll give it another 10 to 15 seconds, and then I'll start with the actual question. Okay, so here comes the points. I'm going to use -1, -2. I'm going to use -1, -3. I'm going to use -4, -2. -4, -2. Oops. Offline. Okay, try and do it better than I did. So there's our triangle. This is the base of it. So for all these demonstrations, I use triangles, but of course, any shape can be rotated, any shape can be translated, any shape can be enlarged, etc. So we had a little look at that yesterday. All right, so this is shape B. Point P then, I'm going to put at 2 - 3. No, I won't. Sorry, that's the wrong place. I'm going to put at -1, -1. That's point P. Okay, so I'll give you a second to get all that, and then I'll start with the actual answer to this question. If you want to have a go at it, go for it. You may not have tracing paper though, so that's the problem. But when you actually do one next week in class, you'll have tracing paper. Okay. So let's look at the question. Point P, well, that's the center of the rotation. Sometimes you just say the point, or they might give the coordinates. So the point P is at -1, -1. We see that up there. -1x, -1y. Okay, so clockwise, it's gone a bit blurry for me. Clockwise is going to be this way. So that's the way we're going to turn it. I know none of you have paper. That's why you're just going to watch me do it and put in the answer. And then when you get a chance to do it yourselves next week, you can always fall back on this video and your notes. Okay, 180 degrees. So that's going to be, remember, I'm just going to take this down here. If your paper is in the original position, start. One rotation that way is 90 degrees, and do put this in your notes. If I rotate that again to this way, that's 180 degrees. And if I rotate it again to that way, that's 270 degrees. And if I go the full way around to the start, that's 360, but we're never asked for that, so we'll stop there. So that's a quarter, a half turn, and 3/4 of a turn. Okay, so you can pop that into your notes as well. Okay, so now I'm going to do it. None of you have this tracing paper. I do, lucky me, but you will have it next week, as I said many times. So, step 1. Make the shape on the tracing paper. Anywhere on the paper, doesn't matter. So if you do have this, I'll use a pen just because it's clearer. Just going to trace my shape that I need to move. Hopefully I'll do a better job than I did last time. It's a triangle like that. Oh, that's not a better job, but all it needs to be a sketch. Just definitely need the corners. Definitely need my corners. Okay. All right. So that's shape B. And now where do I rotate it around? Well, I'm putting my pen on the center rotation. So this time they've given it to us. It's probably easier when they actually give you the center. It's easier to draw than to maybe recognize, because you can just put your pen there. So I can spin it away on my pen. Notice the way it's spinning around that one spot that I have my pen. You can put your finger there wherever you want, but I think it's easier for you guys to see if I use a pen. Okay. So clockwise, I need to go this way. This way. That's terrible. Oops. All right. Clockwise, I need to go that way. So I'm going to go 90 degrees first. That's 90 degrees. And now one more turn of the paper to there, and that is 180 degrees. So I wonder, does that look like what you thought it would look like? All right. So how do I draw that? Well, I kind of need to pull back the paper and kind of put those points where it should be. So they'll be on the whole numbers. So I can just pull back the paper. I think -1, 0 was 1. Put it there. 1 is up here at -1, 1. Pull back the paper, put it in. And the last point is at 2, 0. So I can pull back and put that in. Now you can put those points in. So -1, 0 and -1, 1. Join those two. This is my shape, and then here we go. Okay, this I'll call B dash, the image. So remember, this is we still use the words object and image. All right, and I'll just double check when you guys are doing that I have that in the right spot. Okay, so I should just see it land there. So that's 90 degrees, 180 degrees. Oh, it's slightly off because I moved my pen, didn't I? We're going to try that again. 90 degrees, 180 degrees. There it is. 180 degrees. And 270 would be here. That's 270 if I was asked that. And this is back to 360. Now, interestingly, 180 degrees clockwise is the exact same as 180 degrees anti-clockwise. It's kind of halfway around, because this is 90 degrees anti-clockwise, and there is 180 degrees anti-clockwise, going the other way. They're the same. That's interesting. Okay, so hopefully you have that in your notes now. All right, so there's only one task for you guys to do today, and it's back to my maths. And I'm going to just run through that with you now, and then let you go and start it. Don't start it just yet. Okay, so I switch cameras to this camera. Just share my screen, and then let you off. Okay, so here we are on the rotations homework. So for each of the ones on the first page, you need to find the center. So it does say you can copy these diagrams onto a piece of paper first and do them. So maybe you could sketch them out and try them. So it is going to be, the center. So it goes from A to B. So the center of this one, it's rotating either way. Not sure yet. The center is probably around here somewhere, or maybe it's here. So that might be a little bit of trial and error for you guys. But try it, have a guess, and just think about where the center would be, and perhaps you can have, on your one, it might be a slightly different diagram, but the center would be here for this one, around here, so pick a point, around here for this one, and around here for this one. Or maybe up a bit higher, actually, if it's going to spin. Okay, so you can have a go with those centers. The best way to do it is actually take your time and draw out the diagram and try and use some. Usually you can kind of just see through A4 paper. If you have just any piece of paper, you can see through it if it's only one piece, and do that rotation like we did for question 1 in the notes. The angle of rotation then, well, if you think about it, a quarter turn this way is going to leave this shape upside down, so it's more than a quarter turn. So it's more than 90 degrees for the first one. And you got to write in clockwise or anti-clockwise. So they say C for clockwise and A for anti-clockwise. So example here might be if you want to think that's 180 degrees and you think it's clockwise, you can write in 180. Well, 180 degrees can be either or. So you don't need to write in. It's only for 90 degrees. So perhaps you think it's 90 degrees clockwise, you get 90 degrees C. That'd be 90 degrees clockwise. So try that. For question 2 then, I really recommend you draw this into your book. So you can draw it anywhere in your book. You don't need a Cartesian plane. And then you try to rotate the shape, and then you can come back to my maths and put it in. Now if I switch back, so same thing, rotate this. So this would be 90 degrees clockwise. So 90 degrees clockwise is going to end up somewhere here, I think. Maybe here. And 180 degrees quarter, probably over here somewhere. Okay. So I'm going to stop, go back to the previous camera just to finish off. Okay, so a good question from Leah and Ethan. How do you do it without paper? Well, to be honest, you can see through any paper. You don't need the specialized tracing paper. For instance, if I just use another A4 piece of paper, I can see through it. You can see through it. You can see that shape through it, and you can just use it. Any piece of paper. It's just easier with the see-through paper. So if you have any piece of scrap paper, you could use it. I could do the exact same thing here. I can see that shape quite clearly through it. There it is. And here's my center, and I could have rotated. It's just not very clear on camera for you guys to see. So that's why I definitely need to use. If you do it with pen, yeah, you should be able to see it. So if you cannot, everybody can see through paper. If you're still struggling, just give it a go. We'll do it properly next week, but this is just your introduction to it. So see, and maybe, yeah, with a light on it, it's definitely easier. Yeah. So give it a go. You've got 10 minutes left in class to do it. Otherwise, it is due for homework on Monday, along with clearing all your My Maths tasks. But this is the only new one. So most of you have that done already. So you're now free to go. Give it a go, and we'll look at it on Monday.
Thank you, Mr. Collins.
Thank you.
Bye.
Thanks. Bye.